Now, this is the easier one. Quadratic functions always are of the form ax squared plus bx plus c. Here, a equals 1, because there's an invisible 1 in front of that squared, isn't there?
Yep.
B is equal to 4, and c is equal to -5. What we're going to do right now, a has to be 1. When a is not 1, it's a little more complicated, but it has the same basic structure. That's why I'm starting with a equals 1, and we're going to expand it out to a is not equal to 1. This is called the AC method. First step, always when I factor, is I look for the greatest common factor. Do you see any factors that are in common to t squared, 4t, and 5?
No.
No, there's none. So we just say 1.
Oh, okay. Okay.
If there's nothing in common, there's nothing in common. We just say the greatest common factor is 1, and we move on. Second step. The second step is actually always the hardest. And what we're going to do is we want to find two numbers. I'm just going to say we have a box and a triangle. And we're going to have numbers inside of it. We don't know what they are. But this is equal to a times c, hence the AC method. And for us, a times c is -5. And if I have a box plus a triangle, this is equal to b, and b for us is 4. How do I find these factors? Usually I use letters, but I'm just using this. I'm going to say, well, I need to multiply two numbers together to get -5. Well, 5 is only 1 times 5. 1 times 5. And then I have to add these two numbers together. And remember, this is negative. One of these numbers has to be negative. And if I add them together, it has to be 4. I need to make this a negative, because box plus triangle has to equal 4. Doesn't that satisfy what I said right here? Last step. When I factor it, I take my variable plus box times my variable plus triangle. I get t minus 1 times t plus 5. And now these are the factors. I can multiply these together using FOIL. First times first, t squared. Outer times outer, 5t.
Inner times
inner. Go ahead.
inner times inner.
Minus t. Last times last, minus 5. Combine like terms.
Positive.
And isn't that where I started?
Yeah.
That means I got it right. This is 3 terms with a equal 1. This is 3 terms, a equals 1. Step 1, greatest common factor, 1. There's nothing that divides each one. Second step, I want to find two numbers. M times n equals a times c. A times c, a equals 1, b equals -2, and c equals -24. It's always going to be numbers. A times c is equal to -24. M plus n, last time we had box plus triangle, now I'm just using m plus n, equals b, and b equals -2. I make my chart. If you know the answer, you don't have to make a chart. If you don't know the answer, make a chart. I have to have two numbers that multiply together to give me -24. I start off not worrying about the negative. 1 times 24, 2 times 12, 3 times 8, 4 times 6. It's not divisible by 5. It's divisible by 6, but I already have 6 under my n. So those are all the factors. You could just make this side negative and add them. This is 23, 10, 5, 2. Okay, I know this is my answer, but it's supposed to be -2, which means I'm just going to switch my signs. I'm going to make this positive and this negative, which is going to make that negative. Step 3 is going to be x plus m times x plus n. What I have is x plus 4 times x minus 6. Except this will give me everything but the y's, won't it? Do this. This now gives me -24y squared, doesn't it?
Mm-hmm.
First times first is still x squared. And the inner times the inner plus the outer, there's 4 plus 4xy minus 6xy gives me minus 2xy. It worked out perfectly. All I did is worry about the initial way to do it. And then because I have that y squared at the end, we're just going to tack the y's on at the end. But notice here, a is still equal to 1. We still can use our easier method. This is going to take some practice. Once you do this like 5 times, it'll work out. Step 1 is find the greatest common factor. What is my greatest common factor? Is there anything that is common to all 3?
2.
There you have it. I factor out a 2. And since my leading term is negative, I also factor out the negative, which leaves me with a squared minus 3a minus 10. Step 2. I want to find 2 numbers that equal a times c, and a times c. Now, I know there's an a in here. It's a different a. I hate when they do this, but they do it. But I can say my a, which is the number in front of my variable, is 1. My b is -3, and my c is -10. A times c, -10. M plus n equals b equals -3. Notice I'm only worrying about this one. I'm not worrying about the original because I already factored out that -2. If I make a table, I have m, n, m plus n, and I want 2 numbers that multiply together to give me -10. Start with 1 and 10. 2, 5. 10 is not divisible by 3. 10 is not divisible by 4. 10 is divisible by 5, but I already have my 5. That's all the factors. I'll make this side negative. I'll add them together. Oh, I made the wrong side negative again. Here's my answer, but I flipped the signs, and now I have my answer. This becomes -3. So it satisfies this. M times n is -10. M plus n is -3. My last step. Don't forget, I have my -2 out front. Times x plus 2 times x minus 5. And if you ever want to check yourself, all you have to do is multiply it all back out. These are A's, not X's. Use the correct variables.